Hey folks, today we're going to do a quick tutorial on how to use the image processing code in MATLAB. Method 1, we want to run a few specific images by putting in their file names individually. The first step is put in the right path, and then put in the name of the image that we want to process, and then set method to 1. So we scroll back up to the instructions. In this method, we'll call the images individually, one at a time. After putting in the right path, which directs us to the folder containing the images, and then setting the variable called method to 1. You notice that there's a notification that the computer vision toolbox was not found. That's because in this installation of MATLAB, that's not installed. As of the version of this code in September 2019, it's not necessary. Doesn't affect the calculations in any way. It does mean that the output images are unfortunately a little bit less pretty, but that's really okay, since we just use these to check things, and it really only affects the colorful output images. So the output images have been saved, and we got a file called output areas, and this should contain the areas of all the particles that were found in that image. And you can see right here. Okay, so let's run it in a different method. So in method 2, we're going to run all the files in a certain folder. So let's run all the 2 files that are in that folder on the desktop. So I'll leave the variable file names. It's actually irrelevant in this case. It'll just process all the JPEG files in that folder. So I'm going to get it started so that we can read the instructions while it gets going. So the variable path we changed to the folder holding the images, commenting out the variable file names. You can do that like this. Maybe that will help us remember what method we're in, but it's actually not necessary. And then changing the variable method to 2, and then clicking run. So hopefully we process both the images in this folder and create the outputs. While we're on the subject of the outputs, here's where we tell MATLAB which outputs to show. Display output images. We'll put those processed images in MATLAB figures. I usually set that to false because I like to just save the outputs and look at them in the photo viewer app, but that's up to you. You can set it to true if you like to see them in MATLAB figures. Saving the output images, I usually set that to true just because I want a record of them, be able to see that they were processed correctly. And then save data to Excel, that's true. Usually we want to keep that on in case we want to do a Rosum-Ramler fit to the particle areas or something else later on. Then down here we have some troubleshooting options. This is some stuff that we don't really need to touch or really talk about too much at the moment, but feel free to get in touch with me later for more details. Okay, so now we processed test image 1 and test image 2. As before, we have these output images. Now that was test image 2, and we have some processed images from that. So once again, I'm going to just go ahead and delete these processed images, and we're going to check out method 3. So this is the case that we have a bad image, maybe the scale overlaps the dish a bit, or there's a glare or a shadow. So I should mention that first of all, it's best to just take images that don't have these sort of problems. That really will save a lot of time. However, sometimes it happens to me all the time. So we'll change the variable path to the folder that holds the offending image, change the variable file names so it contains the file name of the offending image, change method to 3, click run, and then follow the instructions that come up on screen to process it manually. So here we need to put back in our file name, and let's process test image 2 using a manual method. Okay, finding the scale. So the dialog box, we can bring it back to the front. Please select points on the corners of the scale. So what we need to do is select that point, that point, that point, and just march around the scale in order of these points as if we were cutting it out with a pair of scissors, and then double click the last points. I'll show you what I mean. Click right there, and then we get kind of a line that we can drag. Click right there. Click right there. Right there. And by now you probably get the idea. Now the last one will turn into a circle, and then we'll double click. Okay, now we get another dialog box which says please select the center of the dish, and you can click OK on those, or you can just let them go. You need to be really careful with this. I guess that's probably good. All right, now select a point on the outer edge of the dish. So I like to select right about there, right in the center and the outer edge. Now that'll show us where the circle was placed using the manual method. And from there, the program should be able to find the scale and the dish, and it will not go into the routine where it tries to automatically locate them. Instead, it will just rely on user input. Now this is not really a fail-safe per se. This image could still be too bad to run if the dish is really overlapping the scale, for instance. You can still run into problems. Glares and shadows and lighting are really influential in this procedure, so just be advised of that. But in this case, seems like it's worked out. We were able to find the scale. We were still able to put the tick marks on the scale, and the dish finding honestly looks about as good as it did before. So there you have it, folks. That's how you can run this code in a folder of your choosing, running either all the images in a certain folder, which is very convenient to do batches, running just a few specific images, or running a bad image that crashes in methods 1 or 2. I hope that was helpful. Please feel free to send me a message. Here's another email right now, swackhammer@UC Davis. All right, thank you for tuning in.